Okay, this is our final project progress report number 2. We're still team 4. So the kill configuration is the same as the last time. Same with the target options, nothing changed there. We did make a few changes for the ultrasonic distance measurement system. The pins are the same. This is the same. This
This
is
is the field output test using the integer. And then we made an improvement by implementing a UART to float and changing our function.
Yep.
It's just
The
more
URL
information.
information's the same. Right, we changed our file where we get all the things for the UART by adding the UART transmit float method, which takes in the float that you want to transmit and then an integer of how many decimal places get transferred along with it. Right, just so you can control the precision you have and you're not left with a bunch of extra zeros. And same thing, just added those methods to the header file here too.
So in all, for the sex sensor, there's a lot of improvements were done where it was made more accurate by implementing float values. So we changed the UART float function, and then we made the echo duration and distance. We made that a float as well, both the start time and the end time and the total distance. We also looked into the echo duration function itself, and since we're using a float as an integer, we changed some of the function for that to not look at the rounding methods anymore. So you just have the speed times the time divided by 2. When looking into different ways of delays, we finalized the DWT functions because when other groups tested other delay types, it did not work. It did not work with what we're using. Finally, for the overall test, the overflow test values, we put in some sample values to verify that when there was no overflow check, it would go to 0. So implementing overflow allows the counter to keep to reset the counting if it went too far.
Now to the IoT project. All right, sensor information and the I2C setup is all the same. What's new is the I2C write method, right? We got this done this week where we can write to our sensor over I2C, which enables us to turn it on. And as a result of being able to turn it on, now we can actually get sensor values, which we are able to read. And after doing the calibration, we print them here. So right now, we were just had it here to verify that we were getting accurate temperature values from our sensor. And these are in Celsius, by the way, right? So we're getting around 23.5 degrees Celsius when we start. And then as it heats up a little bit, it settled around 25.9 degrees Celsius as the sensor heated up. Yeah. And this also used the new UART to float that we were used for the last ultrasonic project. Right, just useful all around getting that done. Next, we started working on the Wi-Fi a little bit. We enabled or made this method to enable the Wi-Fi chip. Basically, we have to set pin F15 to high to enable the Wi-Fi chip. So we do that first. And now to communicate with the Wi-Fi chip, we have to do it over SPI2. So this here is our initialization for SPI2. We start by just establishing all of the GPIO pins that are needed for the communication and getting those configured right. And then we enable the clock to SPI2 and set up the configuration registers. Right, so we're setting it to like most significant bit first, the size of each frame, the clock phase, the baud rate, and setting it to master mode. So that's what we have done so far, right? So the improvements we needed to complete from last week, we finished with the sensor, right? We can now read temperature data off the HTS221 sensor. This also means we can read humidity data off of it. It's a very similar process, right? It's only a few extra lines of code to get the humidity data. So that shouldn't be an issue. The next improvement for enabling Wi-Fi on the board, right? We're able to turn the chip on and we have the communication channel set up. Now we actually just need to read and write over SPI, which that's probably going to take us a little bit to get that figured out on how to get the communication working so we can actually connect our board to the internet and start uploading data. And so for setting up MathWorks ThinkSpeak, we didn't make any progress on that because since our board can't connect to the internet, we didn't really see a reason to get that done because it wouldn't do anything yet. And that's where we're at with our project so far.